you're going to take the mass of the cup and water, 131.9 minus 101.9, and that's not 28, but it's close enough. It's 30. Okay, that's how much ice I added, was 30 grams. All right, next step is to do the calculations. So, the heat that the warm water lost is simple because we're just doing MCAT. The heat that the ice gained, first the ice is going to melt. So we're going to have the ice is going to start out at 0. After it's melted, it's going to warm. So this is actually backwards. This is the heat needed to warm the water once it was ice. So it starts out at 0. It's going to warm up to whatever our final temperature is. So to figure out the heat needed to warm the water, we're going to use this. That's heat gained. And to figure out the heat needed to melt the ice, we're going to use this, which is Ma. All right? So find the mass of the water. For my water, it was 81.9. What's the specific heat of water? Hopefully you've got it kind of memorized now, 4.18 joules over grams degrees Celsius. And my temperature change was from 44.6 to 13.2, which would be 31.4. So that's the heat that my water lost, my warm water lost. So if I do that math, 81.9 times 4.18 times 31.4 gives me 10,749.5. Now I'm going to calculate the heat that the water after it was completely melted gained. So I need to know the mass of my ice, my mice. My mice was 30 grams. The specific heat of water, because it was already melted, is 4.18. And my ending temperature was 13.2. So 13.2 minus 0 is a change of 13.2. All right, now I'm going to do the mass of the ice times the heat of fusion of the ice. And that value is 334 joules per grams. So you're going to take the mass of the ice, which was 30 grams in my case, times 334 joules per gram. So we aren't going... Actually, you're going to not times that. That's the actual value. You're going to solve for this. All right? So if we do 30, if I have 30 times 4.8 times 13.2, it comes out to be 1655.3. And then we add that to 30x. And now we're going to solve for x. Okay? So 10749.5 minus 1655.3, and I'm going to divide it by 30, and I get, and this is in joules, 303.1 joules per gram. That's what we solve for. Percent error is the actual value minus the expected value, or the experimental value, and divide the difference of those two by 344 times 100. So if I do that, I get an error of 9.2%. What kind of errors could have happened in this lab? Well, first of all, there's the error of too much ice, which 7th hour had. There's the error for me for not writing down my ending point, and I had to guess how much ice. I didn't weigh my water plus the melt from the ice. There was heat escaping from the top. We needed a lid. You might not have stirred. Stirring's important. You might not have stirred constantly. That could affect it. What other thoughts do you have? Write down any other thoughts you have on errors, and then we're going to go ahead and turn them in. You can just turn the whole package in. Thank you.